For this tutorial, I'm going to be covering the stream module, which allows you to sync up many integers, even thousands of integers, in no time at all. And we're even going to be covering a little bit of very basic save load, no security or anything, just the absolute basics. And it'll even be using file I/O. And I have another computer on with me, so we can even test it out and so on. And I have a map over here that I've populated with various units for fun, for testing it out. So, to begin with, let's start with loading a file. That's the first thing that needs to be done after all. And then after we load it, we'll start up a timer that'll save it like every second or something. And that'll be that. So let's do that first. So we'll do local file is equal file. In fact, let's not even make this local. Let's make this public. File. So we're going to set file is equal file.open. How about we do my first file again? And let's go and it should be my first map, my first file, and then the read flag, file.flag.read. So after this, let's assume that the very, very first value in this file is going to be the count. And in fact, let's use a special library called bitint to read this file. So I'm going to do set int equal to file, or bitint.convert string file.read, and then it's going to be 6. Now if you don't know what I'm doing here with the bitint, don't worry about that. That's not the important part. This is just so the stuff's easier to use. So now that I have gotten the very first integer out of the file, let's assume that it only has one line to keep things simple. So I'm going to go call file.close. And yeah, we'll keep it simple. So now that I have gotten my bitint, we could actually have this local instead. So local file is equal file.open, keep the bitint up there, and then call file.close. After this, I'm now going to implement streammod. And we are going to have a local this type this now. So streammod gives you a few methods for synchronizing lots and lots of integers. The first method is the allocate method. Set this equal allocate. And the allocate method takes the number of integers you want to allocate. So let's read out of the bitint. So bitint.read. And this takes the number of bits to read. So let's say that we stored it in... We're never going to have more than 256 integers. So how about 8 bits? So now we have passed in the size, how many integers we want to synchronize. And that's just the very first integer in this bitint here. Then we're going to call this .synchronize. So now this will synchronize all of those integers that count there. And then we're going to do stuff here, and then call this .destroy. Or rather, this .deallocate. Normally the create method and destroy method are used for setting this sort of stuff up and then clean that sort of stuff up. Like call int.destroy here. But we're just keeping it simple for now. Now up here, when the stream mod runs, it's going to call a couple of methods that we have to define. The first method is called private method getNextBroadcast, and that takes nothing and returns an integer. And this is supposed to be sort of the reader, like going through an array, the integers we want to synchronize. So over here, if we assume that every single integer is, let's say, a maximum of 32 bits, then we're going to go return int.read 32. So that is literally all we need to do there, and that will return the next 32-bit integer. Yep. So the next method we can use is the private method broadcast %complete, which takes an integer player ID and a real percent and returns nothing. This is an optional method right here, optional, and it is called by the stream mod whenever an update occurs for the broadcasting, the synchronization. And so this can let players know how much of the synchronization is currently complete and how much is left. And what I like to do is I like to declare a private integer low right here. And then if player ID less than low, then call clear text messages. So I just display it via text messages, pretty simple. And so the player IDs are iterated over, and every time it resets, it clears the text messages. And then I just call display time to text, get local player, 60,000, and then I'll go like get player name, player ID, plus R2S %. And then I'll say plus complete. And that's literally it. Nothing special. So at this point, stream mod is literally done. The only thing that needs to be done now is handling that data. So I'm going to do how about another method here? Private method handle, how about static method handle data? Takes integer player ID, and how about just we'll just make it non-static, and that'll be simple. Nothing returns nothing, and method. And so I'm just going to call handle data there. Now let's say that we stored the data, that we just stored units, unit health, and if it's a hero, we'll store the XP, and if it has mana, we'll also store the mana. And we'll store it in that order. So we store unit type ID, unit health, if mana, store mana, if hero, store XP. And these are all going to be 32 bits, so that makes things really simple. In order to read the data out of the stream, you'll have a couple of variables here. First, you'll need a size variable, or how about a count variable. Then you'll need a player ID variable for iterating over all of the players. We set the count equal to, well, how about we iterate first? So we set player ID equal 11. And we do our little player loop here. Well, Then above here, now we set the count equal to size player ID. So this is from StreamMod, and this just returns how many integers were synchronized. So then we loop and loop, exit when 0 equal count. So if nothing was synchronized, then it's going to be empty. And then we are going to start to read it. And in fact, we should read it in order from front to back. So we'll have local integer index here as well. And then we'll set index equals 0. And how about index equal count? Index equal index plus 1. Since it goes from 0 to count minus 1. So now there's another method here called read. And it takes a player ID and an index. So the first value up here is the unit type ID. So we'll go call create unit player ID. And how about we also store the, no, let's not store the x and y. We'll just create them at like -200 or something. In fact, let's look over here. How about the start location? That's always good. And then the player ID was stored, so we're doing the unit type ID was stored. Read player ID and then index. So there's the index. And then get start location x. Start location y. And then how about just 270 for facing? And we also need a unit variable here, don't we? So we do set u is equal to create unit. Now we also have the unit health up here. So call set widget life u equal to read player ID index plus 1. So we should be just saying that index to equal index plus 1 up here. And then if it has mana, so if get unit state unit state max mana greater than 0, then we read the mana. Call set unit state unit state mana read player ID index. And I see a typo right here. And then if it's a hero, if is unit type unit type hero, then set index equal index plus 1, call add hero xp, or we could just do set hero xp, call set hero xp, u read player ID index false. And then we do set index equal index plus 1 again for the next unit, or the end, whatever comes first. So after that, all that's done, the unit was completely read out. And that's all that's needed for the loading. So call handle data, call in.destroy. Everything's done for loading. Let's try saving it to see if it generates any syntax errors. Looks like I made a couple here. Oh, just missing parentheses. Not too bad. Or not a missing parentheses. Oh, I know it's wrong. And got a couple of other errors here. Yep, lowercase file. And that's all. So we didn't have to read multiple lines out of the file because we just stored everything on the first line. We could have stored multiple lines on the file with just various integers, but this is easier here. to do it like this, and you'll see why soon enough, because the count isn't known until all the data is put together. And by using a bit int here, we can reserve space at the start and then write the count to the start. You'll see what I mean there in a bit. So now, after do stuff is done, we'll call timer start, and I'll have this run every second. Create timer 1 true function this type dot save. So now the game is going to save every second. And I don't recommend this for actual games. I recommend just doing a save command. And the reason is because the file generation for the writing freezes momentarily. So you don't want your game freezing every second. That's not really cool. So now that's saving, we probably want a way to get these units. So what I'm going to do is create a group, or a group array rather, groups, and then on init I'm just going to go local integer I equal 11 loop and loop exit when I equals 0 set equal I minus 1. I'm going to create the group. Set groups I create group. We'll see why in a bit. Now I'm going to implement unit index struct, and then I'm going to have private method index takes nothing, returns nothing, call groups get owning player get indexed unit, call group add unit, and then get indexed unit. So now these groups are going to be populated with all the units that the players own. And hopefully I did not screw anything up here. Cannot convert player to integer. Get player ID. There we go. Deal with some more syntax errors. Good. It works. And over here, I'm going to actually do this in a module initializer to make sure that those groups exist. Now I'm going to have another, I'm just going to throw it in here. And then I'm going to make another struct up here. And now that should be good. So the data's been handled, now it's saving time. And we have access to all the units. So, in order to read those units, how about we instead do static, or rather unit array units, and then integer unit count equals 0, and we'll just make these local values. This is even better. We'll go down to index, and if get local player equal to get owning player get index unit. I have no idea if any of this stuff is going to desync or not, but I'm going for it. Set units unit count equal get indexed unit, set unit count equal unit count plus 1, and F. Okay, now it's all local. So for the saving, I'm going to do local integer I equal unit count, and then loop and loop. And how about we keep everything in order here? So we'll go count, index equals 0, loop exit when index equal count, index equal index plus 1, and then in the middle here we're going to do the saving, and we're going to need a file here. Local file equal file.open, and what did I name it? My first map, my first file, file.flag.read. And in fact, we're going to want to do some clearing up here as well. Clear the created units. So we are going to want to do private static method clear units, and they're local, aren't they? So that's not going to work very well. We could do a group enum to clear the units. So local group G equal create group, call destroy group G, set G equal null, then a local unit U is already there. So if count greater than 0, then end if, call group enum units of player G, player ID, and then null. Then loop and loop, set U equal first of group G, call group remove unit GU, exit when null equal U, then if is unit indexed U. This is because some units might not have locust and be system units. We don't want to remove those. Call remove unit U. Done. And then of course we are going to want to set the count equals 0. So if get local player equal player ID, then set unit count equals 0. So we're resetting that local variable there. Now down here, this is all good now again. So for the saving, we are going to go saving in order of these, aren't we? So let's go ahead and copy and paste that down here for a reference. And then we did it with a bit int, didn't we? And did I close the files up here? Yeah, there were no other files, so don't forget to close your files. So now we'll create a bit int, local bit int equal to bit int.create, and then I'm going to set the bit group is equal to 6, and there is a reason for that for later. No, I can set it later. You should never set it until you're about to display it or something. So we are going to now call int.write, and then what do we have here? 8 bits. So this is our count right here. The very first thing we're doing is the count. And we're just writing 0, and it's going to take up 8 bits. Then call int.write get unit type ID, and it is units index 32 bits, and we are going to do call int.write get R2I get widget life units index 32. Oh, 32. There we go. Call int.write. Oh, now if it has mana, if get unit state units index unit state max mana, greater than 0, then call int.write, R2I, get unit state, units index, state mana, and it's going to take up 32 bits as well. And then if is unit type unit type, units index, unit type hero, then call int.write, get hero xp, units index, and that'll also take up 32 bits. So everything's been stored, and it loops through all the units. Then at the end here, we're going to call int.overwrite, and it will be the count. So we should go, how about a local integer data count equals 0. Every time we write data, we increase the data count. Data count plus 2, data count plus 1, set data count equal data count plus 1, and then it.overwrite, we're passing in the data count. It's going to take up 8 bits, and it's going to be at position 0. So this will write into this reserve space we had up here with our data count. And then we can call file.write int.toString. Oh, we should also set the bit group now. Set int.bitgroup is equal to 6, int.toString. Then call file.close, call int.destroy, and that should do it. Now we get to try it out. Okay, now I actually paused this and went around fixing all the bugs up here. And even the bitint library actually had a couple of bugs in it. So now it's completely verified to work, and this is the folder the data is saved into, so Warcraft 3 directory. Game data, my first map. So let's go ahead and test it. So bringing Warcraft 3 up now and going to local area network, create game, and that's the map. And now I'm joining on the other computer. There I am. And starting the game. And here we go. So the 100% complete thing was just loading an empty file. If we look at my first map, a file just popped up here, and if we look inside of it, there is data right there. This data here is the actual code. It's relatively long because all of the data was saved as 32-bit ints. But as you'll see in a bit, it really does load up instantly. So now I'm going to go ahead and attack some monsters. And the health and whatnot is going down. So like right there, 339 health. XP is a bit higher. Not too bad. Okay. So now I'm going to exit. And then I'm going to rehost it. and you are going to see just how instant that huge code took to load. Not many integers were saved, only 3 per unit and 5 for the hero. So it's loaded almost instantly, and there's the original data. So as you see, this guy's hurt, and this guy has 50 XP. And can even attack these guys up here again, and keep playing this over and over again. So let's go back and look at the code really fast to see what kind of changes I ended up making. Really, nothing major. I added an if statement here, % greater than or equal to 0. It's because all player IDs are passed into broadcast % complete, whether they exist or not. Non-existent players are shown with -1. And this is to show, for example, when a player leaves the game, if you want to detect that. What else did I change? I moved, this was outside of this if statement before, so the unit count was gained set to 0, meaning that none of this would run. And those were the only 2 things I changed. Bitint I fixed. It was a little bit messed up. It wasn't reading bits correctly, and it was passing in a couple of wrong parameters. But that's all fixed now, so everything appears to be working perfectly. Anyways, this is how you, you do rudimentary save load. The only thing you would add to this for full save load would be encryption and some sort of checksum, and the encryption and checksum are now very, very easy. And also with the new resources that are coming out, you won't even have to worry about these bit sizes. It'll just automatically determine the bit sizes for you. And once again, this overwrite is done because the data count isn't known until you collect all the data. So the data is written to the bitint, and then at the very end, at the very front of the bitint, the count's written. And this count is the very first thing that's read out of the load method, which is in do stuff. So right there, very, very first thing read right here. Haha. And that concludes this tutorial. Hopefully you learned a lot. The big things to remember is for the stream module is just get next broadcast, and you're just returning the next integer you want to sync. So this just reads out of that bitint, which contains all the integers we stored down here. So, whoop, that's the reads again. So the writes, int.write, int.read, and you're just reading from front to back in both cases, so it's very, very simple. So get next broadcast, that's all there is to it. It's generally 1 line long. And then implement stream mod. And then for the streams, you typically open a file, and you're typically reading out of that file. For more complicated bitints that might span multiple lines, you would still need the file open, and the bitints would be crazy. So you're just, once again, for load, you're just reading the count out. You're allocating a stream module, and allocate's very, very easy. It just takes the number of integers you want to synchronize. Then you're synchronizing it, and you're passing that bit in up to the field we had above. Oh yeah, that was the other thing I changed. I added a local here because this was not initialized. So when I tried to set this, the thread would crash, obviously. So I added the local there to prevent the thread from crashing. So after you do that, you synchronize it. Then you load the data or whatever. So up here we handle the data. So I cleared out the units that were on the map. You don't really have to worry about that normally. And then I loop through every player. If the player had data, I just loaded the data. So I looped through the data and loaded up from front to back. Pretty straightforward. And then finally, after handling the data, I just deallocate. So it's normally destroy. In this case, it's deallocate, because normally you make your own stream struct and then do all this outside the struct. And then I call int.destroy. So I created it up here. I destroy it down there. Then I start my 1 second save timer that saves every second, and that's pretty straightforward. Just file open for the writing. That was another thing I didn't do right. I had this set to read, not write, so that was throwing errors. And then I reserve my count for bitint, and then I just write all the data for each and every unit. So this is the unit loop, and here's the data being written. And then at the very end, I update the count in the bitint. I set the bitint group to 6. This way it converts to a nice string. And then I write it to the file. And at the end I close the file and destroy the bitint. So lots of small pieces here, but the main thing in the stream module is just get next, broadcast, stream mod, allocate and deallocate, and synchronize. So not many pieces to worry about in the stream module. It really is very simple. It's all of the actual handling the data that gets a bit complicated. Like the saving's not even too bad. It's up here. None of this is really that bad at all. It's really simple stuff. And when the new resources come out, it'll be even simpler. So that concludes my tutorial on Stream Module and very simple save load with Stream Module and File I/O. And Packet wasn't used in here. It was actually used by StreamMod though. That size was synchronized with the packet. So packets and the stream module are used. You just don't have to use the packet yourself. It's used in the background.